Xbox Series X. Let me show you what's going on. Alright, as you can see, we have a busted HDMI port. So that's going to be the job of the day, is to disassemble this Xbox Series X and remove this port. And hopefully you don't have any. Usually on an Xbox Series X you don't usually have a whole lot of collateral damage, but we won't know until we get that. This video is brought to you by PCB Way. Did you know PCB Way offers services beyond PCBs? Services like CNC machining, sheet metal fab, 3D printing, and injection molding. Check out my associates link in the description for a $5 coupon off your first order. Now back to the repair. Okay, we have the board out of the housing. Let's switch you back to Microscope as we set up. Okay, and our approach is, as always, is going to be to flood this area with low melt, flood these anchor points, and then we're going to flip the board over and remove it from the top, which is not normal for us, but with this board there is actually, I can show you. So with some additional lighting I've been able to brighten that up a bit. You see that yellow spot right there? That is plastic, a very high temperature plastic, and it is bonded to the HDMI port, which makes the first replacement of these HDMI ports very challenging. So we will be removing from the top because it will not just fall off. We have to actually physically break that connection. So what we will do is low melt these anchors, but before we do, let me throw up my temperatures, expected temperatures for this job. As always, they are subject to change if the job changes, but I don't expect the job to change too much on this. It's going to take everything our hot air station can pump out to rework this board. As always, these temperatures are brought to you by the Amazon associate links in the description. If you click on any of those links and buy any of those pieces of equipment, or if you buy anything during that session, a small portion of that will go to supporting the channel, and it will not cost you an extra dime. Greatly appreciate it. Let's switch you back to Microscope. Let's flood these anchors with low melt just to help out a little bit. Anything that helps out with removal of these ports is a good thing. Rub it in real good. What we want the heat to do is climb up the leg and draw the solder with it. Ideally, feed through to the other side. Okay, so I put this block of aluminum. I have some silicone protecting the board from the aluminum. You don't just want to put something hard on the board because it very easily could knock off components. So I put some silicone on the bottom, and I put this block of aluminum. I need some counterweight for when I'm lifting on this port. I will be logging hemostats onto the port so I don't have to worry about the tweezers falling off. And actually, I'm also going to low melt the pins, just so it's one less factor. Rub that in. I don't care if it bridges. I want it to work its way under the pins as well. That is just so we don't have to worry about the pins wetting or pulling pads. They will be well wetted by the time this port pulls. Let's get after it. I'm going to start in on the pins just to get them wetted right away. We have hidden anchor points under this port that we have to worry about too, but there's nothing we can do about them. We just have to wet them naturally. Now we'll start concentrating. Now that we have those pins wetted, we'll start concentrating in on the anchors. By the time the anchors are ready to go, it'll be pretty easy to get those hidden joints done. I'm really going to focus in on one side, so I see some wetting. Takes a good long while to get this board hot enough to remove a port, so just be patient. Don't do damage because you're being impatient. They're going a little bit, but nothing too difficult. Just gentle. Very good. We broke the bond. No pull pads. That's what the low melt was for. Let's add some flux. Generous amount. These are the hidden joints I was talking about. There's nothing you can do about them. You just have to be patient when removing the port. I'm going to mix some leaded down to those just to make them easier to wick. Don't scrub with your wick, you're just gliding over it. If you have to add more low melt, add more low melt. Adding a little bit more low melt to these anchors so I can get them completely cleaned out. I'm very stubborn. Wicking could be such a good time. Good gravity. Clear out already. It's getting stupid. Be real careful around these guys here. You don't want to accidentally knock one off. Won't be fun times. I'm going to put a nice bowl of 6437 solder. Kestra 44 on our iron. And ideally we just want to make contact with the solder mostly and not the iron itself. We have to do so to clear some bridges, but should work fine. In this case, we do need to tin our hidden anchors as well. Alright, so I am going to make a little contact on these because they are anchor points and they don't take solder very easily. You have to kind of rub it in to get it to take. Get that thing heated up. We're going to prep the port. Generous amount of flux. Decent amount of solder on the tip. And we're just going to tin our pads. I don't mind if they're bridged. I'll chase the bridges. It's much easier to chase the bridges on a port that's not installed than a port that is installed. Alright, I think we got them all. Okay, we should be a go for flow in. This will not take quite as long because we're not doing the anchors, the visible anchors anyway. And we're going to flow it in using the very similar method to the one we use for the Nintendo Switch. Rapid air movement, bringing up the temperature of the board enough to wet the solder. I'm going to concentrate in on the pins because that's what I want to get first, and then we'll worry about the hidden anchors. I am moving the air rapidly so that I am not sitting in one place long enough to burn anything. There is plastic in the connector that we do not want to burn. Guys a bit. You can see when they float. I didn't clear all the bridges, but they should clear once this flows. We'll check afterwards though. Okay, start concentrating in the hidden anchor area. Be patient with this as always. Okay, I'll start pressing down. Give these pins one more good flow. And we'll pull the air and see how we did. I'm going to hold it down for a bit because it will take some time for this board to cool down enough to dry the solder. Alright, we'll do a little nudge test like we do with the Switch. Shouldn't get any play at all. Shouldn't move a bit. And it's not. Very good. Seems very solid. First glance, they look pretty good. And everybody is solidly in place. Very good. Looks like our hidden anchors for the most part. I've soldered down. Very good. Let's get these anchor pads flooded with some Kestra 44 6337 solder, which you can find in the description. And you want to feed a generous amount in there. Trying to get feed through to the other side of the board, so the more the merrier. There can't be too much, but you'll figure it out as you go. And you can very well see solder from the other side on the anchors. And that's what you want. That's excellent. I'm going to clean up off screen and then we'll come back for a final inspection. Okay, final inspection. We'll get in on these pins a bit. And as you can see, nice fillets. Every pin is covered in solder. And it looks perfect, other than a little bit of blue thermal crap that's gotten in there, but I'm not going to worry about it. It's non-conductive. Alright, next thing to do is put it back in the housing and we'll give it a test. Okay, and as you can see in the top left, we are back up and running. It needs to be configured, but that's not something I handle. And that's really going to be it for this one. If you like this video, check out the next one right there. And I'll see you over there.